Okay, so the first worksheet, grade 11s, we're going to have a look at. We're going to skip topic 1, which is vectors in 2 dimension. We're not going to skip it, but we're just going to bypass it for now, because topic 2, which is our main exercise, where most of the like the grade 11 question that I showed you in the exam last week, is not really focused on vectors in 2 dimension or vectors, but rather focused on Newton's laws as well as the application. Okay, that is a big deal. All right, you are tested or will be tested a lot on the application of the law. Okay, how well you apply it. So on this little worksheet, I'm not sure if everyone is able to see it. Maybe I'll make it at maybe about 85. Maybe it's a little bit bigger. A 3 kilogram box is resting on a horizontal surface. The coefficient of static friction between the surface and the box is 0.34. Okay. Number 1, they want you to calculate the weight of the box, and that is for 2 marks. So what's nice about this worksheet is that it gives us a clear indication of the mark allocation for the amount of work that we need to do to get the mark. Okay, you look at the mark allocation. That's how much work you need to do. So the first one is calculate the weight of the box, all right, which is very basic. The second question is now calculate the maximum force of static friction between the box as well as the surface. Okay, we're going to go ahead and we're going to do that. So let's first have a look at calculating, of course, the weight of the box. Okay, so I'm not going to ask anybody to talk me through this one, but I'm sure this would be, we can call this, as it's called, topic 2, which is Newton's laws. All right, and to shorten it, we can just say and application. Okay, very awesome. Cool. Now, first one, I'm not sure if it is 1.1. Let's see. Yeah, it is 1.1. Calculate the weight. Well, we know that weight, W, is equal to mass times gravity. So weight equals mg. It's perfectly fine, right? And then what we can do is we can just substitute. This was a 3 kilogram block, so 3 times 9.8. And this I will leave up to somebody. Can somebody please tell me what is the answer for 3 times 9.8?
29.4.
29.4. All right, so that would be a force, so it would be 29.4 newtons. All right, I'll just double check and confirm, not that I don't trust you, but 29.4 newtons. So please, grade 11s, of course, this part here is very important. If you don't state that in your answer, this whole thing is wrong. You'll get 0. So don't make that mistake. Let's have a look at the second question. The second question, 1.2, is calculate the maximum force of static friction between the box and the surface. Now that's for 3 marks. Okay, so what we do understand and what we should remember from previous lessons, especially those who are busy with frictional force right now, is that it is static friction is the first thing we need to have identified there, because the coefficient of static friction is 0.34. Okay, so what do? We know that the static frictional force, Fs, is equal to the coefficient denoted by mu s times the normal force. Right, that is our formula. That'll be 1 mark in the exam. Okay, so to substitute, because just to go back to the question again, they say calculate the maximum force of static friction between the box and the surface. Now I must make you watch out for something, ladies and gentlemen, is notice the way they've worded it. Okay, they obviously want to try and trick you. Okay, so they've said calculate the maximum force of static friction. Now that, believe it or not, I've seen many physical science students over the years of my tuition, and when I was in school, of course I had friends that did the subject when I did the subject, classmates, etc. And it threw them off. It used to throw me off. Even if it was for 0.5 seconds, it's still a bit of a throw off. Okay, don't be thrown off. They are asking you for this, the force of static friction. Okay, so even if none of you were thrown off by that question, it was worth mentioning, okay, because some other questions you are going to discover and find that they are designed to maybe throw you off because they're not clear or they worded a different way. Back to the question, 0.34 was the coefficient. The normal force we know is exactly the same as the weight or force of gravity, because it's in the opposite direction. So we just plug in 29.4, and someone else have an answer for me here. Easy calculator work. Let's see if anything comes in the chat. No, nothing.
JP, I got 9,996.
9,996. We can round that up. So we'll 996. Yeah, if it's 99, definitely round up to 10 newtons. Okay, and that is the maximum force of static friction. All right, pretty basic. Okay, though that first one, I'm sure we all fared well on that first one. Okay, so what we'll do now is we'll just pop to the second one quickly. Okay, now second one, question 2, so for 2.1. Okay, what I'll do for 2.1, let's read it first. Rugby players are trying to push a 500 kilogram scrum machine along, well, I think there's a missing a word there. Oh, no, it's not. Along horizontal ground. The coefficient of static friction between the scrum machine and the ground is 0.65. 2.1, calculate the normal force acting on the scrum machine. Okay, very interesting question there. And 2.2, calculate if the players exert a horizontal force of 3,000 newtons on the scrum machine, will the scrum machine move, and give a reason for our answer. Okay, so I'm going to let you do those two questions on your own by yourselves. It's 3 marks and 2 marks, so that's 5 minutes. At 20 past, we'll mark again. Right, guys, it is 20 past. Now that time has been 5 minutes, so let's have a look here again. So 2.1, they're asking us to calculate the normal force, which we know is opposite to that of the gravitational force. So essentially we are calculating the same thing here. Alright, so what we do is we'll just say, well, 2.1, if W is equal to mg, then that means the mass, which is 500, times gravity, which is 9.8. Does anybody have an answer here on this one?
4,900 knots.
Are we calculating the wind?
Oh, Newton, sorry.
Just making a joke. No, it's fine. Just making a joke. All right, awesome. So it's 4,900 newtons. Okay. So in this case, weight was equal, or weight 4,900 newtons. So we could say therefore the normal force is equal to 4,900 newtons. Right, and that's still correct. Okay, and we can put a direction of that because remember it's a vector. Force is a vector, so it is 4,900 newtons. We can either say up, or we can say perpendicular to the ground, because that's what the normal force is. Perpendicular to the ground. Okay, because weight is going down. Okay, weight goes downwards. Okay, which you can also say here, down in the first one. Okay, awesome. Alright, that was 2.1. I'm assuming most people got this correct. Okay. And the second question was, now if the players exert, alright, they exert a horizontal force of 3,000 newtons on the scrum machine, will the scrum machine move? Give a reason for your answer. Now, they are essentially asking us, okay, is the force that's exerted by the players on the scrum machine, which has been given to us kindly by whoever set up this questionnaire or this question activity worksheet, which is given to us as 3,000 newtons. What else have we been given in the question? We've also been given the frictional force, or the frictional force coefficient, the static frictional force coefficient, which is 0.65. Now, essentially, all that they want to know is this 3,000 Newton force exerted by the players on the machine enough to move it? That's all they're asking. So, if we already know the force applied by the players is 3,000 newtons, we need to find out, therefore, what is the value of the static frictional force. All right? That's what they're asking us to do. So, I'm going to use a new page here, so 2.2. How we do that is the same thing. We say, well, the force of static friction is equal to the coefficient multiplied by the normal force. Now we've been given the coefficient and we have the normal force. The coefficient is 0.65 and the normal force is 4,900 newtons perpendicular to the ground. Therefore, the maximum static frictional force, right, between the scrum machine and the ground is, can someone give me an answer? Anybody? Is there?
Someone gave an answer in the chat.
Fantastic. Laika, thank you so much for your answer. Thank you. 3,185, and it's in that answer of newtons. Static friction, so it's going nowhere. Okay, and we also know that force applied by the players was equal to 3,000 newtons. Okay, so therefore the force of static friction is greater than that of force applied. So to conclude, in our final answer, will the machine move or not?
Yes, it will.
Think you want to think about that again, Alex? Look at that again. Our force of friction, the force that opposes movement, is greater than the force that's promoting movement. 3,001. Say that again.
So the force applied must be more.
Force applied needs to be more. So Nadim and Laika, yes, you stated the answer correctly. No, it will not move, right? Because they are applying too little force. They're only applying 3,000. And the force of friction, static friction, which opposes movement, is 3,000 newtons. So they are applying a force that is 185 newtons less. Alright, they are under by 185 newtons. So therefore we can say, because Fs max, or the force of static friction, is greater than force applied, the machine will not move. Will not move. And why? Because, as we stated over there, applied force, or force applied, whichever way you want to write it, of 3,000 newtons is less. Forgot to write less than the force of static friction, or Fs max. Okay. Right, we can see that it is visual. Clearly, 3,185 is more than 3,000. Okay, so that obviously tells us that the force will not move at all. Let's look at question 3. Now, question 3 is a little longer. And as we can see, question 4 also gets slightly longer as well. No longer 2 questions now. We get to about 3 or 4. So question 3 says the brakes on a 20 kilogram cart are locked so that the rubber wheels cannot turn. A child pushes horizontally to the right on the cart until it just begins to slide. So maybe zoom in a little bit. Awesome. Just begins to slide. The maximum horizontal force he applies is 150 newtons. After the child is able to keep the cart sliding with a horizontal force of 80 newtons. So let's read that again. After that, the child is able to keep the cart sliding with a horizontal force of 80 newtons. 3.1, define a normal force. Definition. 3.2, explain the difference between static and kinetic friction. It's quite obvious. And 3.3, calculate the coefficients of static and kinetic friction between the rubber wheels and the ground. This one is also not very difficult. It's quite easy too. Alright, so I'll give you guys, let's see, 5, 6, 7, 8, 9. Might as well give you 10 minutes because it's 5:29, so I'll give you that extra minute. 10 minutes. At 22 we will mark question 3. So let's have a look at question 3. Okay, the first question was define a normal force. Alright, so a couple of definition questions. Okay, so this one, unfortunately, with the definition questions, we can't escape them. They will pop up like daisies. Okay, just when you think you've done enough definition question answering, another one comes up. But define a normal force. Alright, a real question that could pop up in the exam and has popped up in previous exams and tests. Alright, so the first one for the normal force, which I'll give to you, is defined as the force that is exerted by a surface on an object. In contact with. Right, so with it, rather, just to end it off. So the force exerted by a surface on an object in contact with it. Alright, another thing worth mentioning, it is the force, alright, exerted by a surface on an object and is perpendicular to that object's surface. Alright, awesome. So, apologize for that little bit of interruption. One of my family members did not know that I was busy in a class. Apologize for that. Anyway, 3.2. I think they asked us to define static friction and kinetic friction. So what we could have done is just said, well, static friction. Right, and just put up colons there, or colon rather. First of all, we know that it is, of course, a frictional force. We have to start by mentioning that. It is a frictional force that occurs, let's write it over here, between a stationary, right? Stationary with the ARY, okay, not ERY, okay, not the pens and pencils that we write with, okay, but occurs between a stationary object and, I was going to say the ground, but let's rather say and the surface, because not everything is on the ground, okay, and the surface, alright, maybe going further, on which it is stationed, okay, to keep some assonance going. Alright, the repetition of the S sound. Okay, the next one which I'll do in a different color for variation. Let's pick this one, which is kinetic friction. It's obviously different. Alright, this is also a frictional force, but this occurs only when an object is moving, okay, or you can say when an object slides across the surface. Okay, so this definition clearly helps us answer question or understand the question better when the question states that that the cart begins to slide, and he keeps, after that the child is able to keep the cart sliding. Okay, so this definition really helps us there. Okay, sorry, 3.3. all right, 3.3. So obviously we know that they ask us to calculate the coefficients of static and kinetic friction, because the trolley was first, or the cart was first stationary, and then it was sliding. So cool, you have to calculate both. So first things first, we know that W is equal to mg. Alright, so we know that I'm going to do it all in one line. So we know that a cart is 20 kilograms, so 20 times 9,8, which gives us an answer of 196 newtons. Alright, which would obviously be equal to the normal force as well. So therefore the normal force, 196 newtons. Okay, and that's going obviously upwards. Oh, this is going down. Okay, to change color for variation. Now we also know that the maximum static frictional force, okay, we know is equal to the formula mu s times the normal force. Okay, we are told that it applies 150 newtons to a stationary object and manages to get it to slide, and the wheels are locked, right? So it's if he's pushing any other substance or any other object rather that does not have wheels, because wheels are locked, they're not really serving their purpose of being a wheel. Okay, so we assume that the force applied would be equal to the frictional force, or the static friction, or the value of the static frictional force. So we know we have 150 is equal to the unknown coefficient times the normal force of 196. Okay, so to rearrange, we have the divide both sides by 196, we have 150 divided by 196, and therefore the coefficient of static friction is equal to 0.77. To do the next one, which is Fk, or kinetic friction, same thing, we just replace the S with K times the normal force. We told that he managed to keep the object sliding after he applied the 150 Newton force, and he was managed to keep it sliding at 80 newtons. So 80 is equal to UK times the normal force, which is 196. Divide both sides by 196. We get the equation mu k is equal to 80 divided by 196. Therefore, the coefficient of static friction is equal to 0.41. Question 4. A 5 kilogram block, or box rather, is resting on a plane inclined at 30 degrees to the horizontal. The coefficient of static friction between the box and the plane is 0.63. Okay. 4.1, another definition, define a frictional force. 4.2. 4.2 is where the money is because it's the most mark. Draw a neat labeled force diagram, not a free body diagram. I've taught you the difference between the two. A labeled force diagram showing all the forces acting on the box. Draw and label the horizontal, wx, and the vertical, which is wy. In other words, FG parallel and FG perpendicular. Components of weight of the box, and label the angle 30 degrees, or label the 30-degree angle. Okay, after we've done our little force diagram there, all right, 4.3 says calculate the maximum static frictional force between the box and the inclined plane. Also a little bit of money there, 4 marks only. And then 4.4 is use a calculation to explain why the box does not slide down the slope. Okay, that's 4 plus 3 is 7, 8, 9, and 6 is 15. All right, so 15 minutes. All right, so you got 15 minutes to finish this question starting from now. So that is at about 10 past when we will have a look at this question again and see how far we have come. So 10 minutes to circle with it. Have fun. Looking at the first question again, define a frictional force. Now I'm just going to mention this. Sorry guys, give me a minute. I'm just going to mention what it is. Obviously we all understand how to write the definition, so I'm just going to mention it because sure we all know what frictional force is. So of course, frictional force is the force that opposes the motion of an object. That's your first mark, and acts parallel to the surface and the object it is in contact with. Now the reason why, if you just said the first part you would not get 2 marks, is because you've only mentioned one thing about it. The force that opposes motion of an object, that is what frictional force is, but it's only 1 mark. And they asked it for 2 marks. The next part of that is, and acts parallel to the surface the object is in contact with. So in other words, it's horizontal. Parallel to and it's on a if it's on a horizontal surface, so parallel would mean its parallel means it'll also be horizontal. If it's on an inclined plane, it'll also be in the same direction, or parallel, should I say. 4.2, like I said, that's where the money is. They're asking us to draw a neat labeled diagram. Okay, let's go have a look here. So how would I define it? It doesn't matter if you're drawing it from right to left or from left to right, as long as you are showing that the object is going down a slope. Okay. Okay, I'll draw that there. Draw it like that. Okay, there's our 30 degrees. Why? Because I said 5 kg box is resting on a plane inclined at 30 degrees to the horizontal. Okay, cool. I've stated that, I've shown that. Okay, then we'll draw the box somewhere up here. Alright, fantastic. Okay, and we can start labeling our forces, of course. Okay, they asked for the components. What did they ask for? They said all the forces on the box, and then now draw and label the horizontal, vertical components of weight of the box and label the 30-degree angle. Okay, so firstly, all the forces. The first one, Fn, normal force. All right, and going straight down, of course, would be our gravity, but they've asked us to use W, so we'll use W in place of Fg. Okay, then they asked for the components, or we'll drop a line going like this, and we'll drop a line going like this. Alright, going like this in this direction, and we'll drop an arrow going down in that direction. So we know this would be Fg perpendicular, which is the same as W perpendicular, or as they've asked us to label it, Wy. And of course this would be Fg parallel, or in this case weight parallel, but they've asked us to label it as Wx, right, which is the horizontal. X is horizontal, Y is always vertical. And label the they asked us to label the a 30-degree angle, well, 30-degree angle would be over here. Right? That's why. Okay, so that will be the same. 30 degrees that we see over here would be over here as well. And let's just check. The other forces that was obviously in contact with, they gave us static frictional force. So obviously in that direction would be Fs. Alright. And which would be friction, Fs. And we have normal force, we have Wy, we have Wx. And yes, we're not told that there is force applied, so we don't need to worry about that. We are 100% correct. So the mark you'd get for showing the normal force, and also we'd also get a mark for showing Wx and Wy, and that was for 6 marks. Oh, I forgot to label it as 4.2. Okay, some of you might decided to have mirrored this drawing, to draw it that way. As long as you're drawing it down, it's still the same. Right, this one over here, Wx, is the same as if it were drawn here. Wx. Okay, it's the same. It's the same thing. It's both going this direction. Okay, I prefer to draw it over here as I'm showing the components of weight. Okay, cool. I think we might have enough space for it though. Well, we could just make use of this whole space here. 4.3's question was calculate the maximum static frictional force between the box and the inclined plane. They've given us the static frictional force coefficient, right? And we can work out the normal force, I'm sure. Okay. So when it comes to any object that has a vertical component in it, all right, we must understand, okay, that there's going to be a formula that says basically weight is going to equal the normal force plus that of the vertical component, in this case, which is Wy. It's only a vertical component here, right? So this is going to equal to this plus this is going to give us the value of weight. So if you want to find out the normal force, if you want to rearrange the formula, the normal force is going to equal the weight minus let me just see something. Am I doing this correctly? Let's check. I did this question earlier in my notes. Cool. Am I missing something? No. Yeah, I'm missing something. Sorry, I'm explaining something completely different here. Being a bit foolish, so I do apologize. Don't take this down. I know previous tutorial I did show what that was meant for, but you can see in a normal horizontal, the normal force value would be equal to that of weight because they are directly opposite each other. Here, directly opposite, the normal force is Wy, or perpendicular component of weight. So the normal force would be equal to that of Wy. Alright, the vertical component of weight. Now, in order for us to find what is the vertical component of weight, we know weight is equal to mg. Okay, so then that means it's going to equal adjacent over hypotenuse, and hypotenuse is weight. Okay, in this triangle, hypotenuse is weight, which is equal to mass times gravity, right? Cos 30 degrees. Cos 30 degrees, of course, because it's adjacent, which is Wy over hypotenuse, is going to equal cos 30. Rearrange, we have mg cos 30, which gives us 5 multiplied by 9,8 multiplied by cos of 30 degrees, and we get an answer of 42,44 newtons. Okay, now that we know the normal force, all right, we know this Wally, we can go and plug him into our formula for Fx max is equal to mu s times the normal force, which was 0,63 multiplied by 42,44, and therefore Fs max, which is the maximum static frictional force, in this case will be equal to 26,73 newtons. Okay. Use a calculation for 4.4 to explain why the box does not slide down the slope. Very similar to question 3.3, which you can still see, or no, not 3.3, question I think we did previously. Question number 2, would the scrum machine move at the force that the players were applying? All right, that was a very good question. So for question 4.4, we apply similar calculation. So we know that the force of static friction we just calculated, right? We already know this value is equal to 26,73 newtons. Right? Check, we have that. Now we need to calculate the horizontal component going down the slope, which is Wx. Okay, so our drawing, okay, we have a 90-degree angle there. There's our 30 degrees. Okay, the Wy is equal to 42,44 newtons because it's opposite the normal force. Okay, here we have 5 times 9.8. Let's just calculate what that is quickly because I forget. It's 49. All right, and here Wx, which is parallel, of course, to the slope. Okay, so we're going to find out what is that force, all right, or that component of weight. So obviously we know that is opposite the angle, sine, all right, you know it's opposite over the angle, so sine 30 is going to equal opposite, which is Wx, which is what we want, over hypotenuse, which is just W. All right, we rearrange that. Wx will equal to W sine of 30 degrees, and we know what W, which is weight, we know what that's equal to. So we know that is Wx is equal to mg sine theta, or sine 30 degrees rather, which is equal to 5 times 9,8 sine of 30. And therefore the value of Wx, which is the force that it will obviously force going down the slope, all right, in the same direction as the box should be or would be moving, is equal to a whopping 24,50, or just 5 if you wish, newtons. Okay, so what do we notice about the two values? All right, clearly one is bigger than the other. So we discover actually that Fs max, force of static friction, is greater than that of Wx. Right? So the frictional force value is more than that of the parallel weight component force. So therefore, because of this, box will not slide down the slope. And we came to this conclusion just based on the calculations that we had performed. And that concludes our session, our exercise session on Newton's laws and applications. Stay tuned for more, where we will do some more exercises to consolidate this section in physical sciences.